Hello. In today's video, we will discuss about some more concept related to process control. With respect to this one, we are discussing about changing user IDs, group IDs, interpreter files, system function, process accounting, user identification, process times. What about the changing the user IDs and group IDs here? When our programs needs additional privileges or need to gain access to resources that they currently are not allowed to access, they need to change their user or group ID to an ID that has appropriate privilege or access. Which means that sometime what happened, we wanted to run a particular program, but with respect to that program we require some additional privileges or some kind of the resources we require, but currently it is not able to access by using existing user ID and group ID. In that case, we need to change the user ID and group ID with the appropriate privilege here. Similarly, one more point, when our programs need to lower their privileges or prevent access to certain resources, they do by changing the either user ID and group ID to a ID without the privilege or ability to access the resource. That means we are wanted to put the restrictions that I have some resources. This resource can be accessible by only super user privileges. Say for example. So in that context, we need to change the user ID and group ID. So for that concern, we are using the two APIs. One is setUID function. One more is setJID function. So both the functions are accepting only one argument, and they are returning the 0 on successful condition, and failure condition they are returning the 1. So with respect to this one, we are having the three roles. If the process has a super user privilege, the setUID function sets the real user ID, effective user ID, and set user ID to UID. Means whatever the value we are passing here, UID value, that the value will be assigned to real user ID, effective user ID, and saved set user ID. The one point I wanted to clear here. So real user ID is nothing but real owner of the user, and effective user ID is nothing but who got the access permission. We got the whenever we got the super user privileges, so we got the access permission, then that ID what I can call as a effective user ID, and later on when we wanted to save the program, then that ID what I can call as a saved set user ID here. If the process does not have a super user privileges, but UID equals either real user ID or saved set user ID of the calling process, okay, in that case set UID sets only the effective user ID to UID. The real user ID and saved set user ID are not changed. That means only one value is changed. If suppose you are not a super user privileges, then only that value will be changed as saved set user ID. Otherwise, the remaining value will be same. If neither of these two conditions is true, error number is set, that is E permission. That is nothing but you are not having the access permission to access these resources or files here. Continuation of the point here. Only a super user process can change the real user ID. Normally, the real user ID is set by the login program when we log in and never changes. That means when we log in into the system, in that case only we are setting the real user ID, and that real user ID can be changed by the super user process. And one more point we need to observe. Login is a super user process. It sets the all three user IDs when it calls setUID function. That means by default real user ID, effective user ID, and saved user ID will be set. And one more point related to this, the effective user ID is set by the exec functions only if set user ID bit is set for the program file. If set user bit is not set, the exec function leave the effective user ID as a current value. So we can call set UID function at any time to set the effective user ID to either real user ID or saved user ID. Naturally, we cannot set the effective user ID to any random value. That means when I call the exec functions only with respect to that one, set user ID bit should be on. So in that case, so we can set it. If suppose the set user bit is not set, the exec function leave the effective user ID as a current value, will not be changed. Okay. We can call set UID at any time to set the effective user ID, either real user ID or set user ID. Naturally, we cannot set the effective user ID to any random value, means whatever the value you want, we cannot set it. The saved set user ID is copied from the effective user ID by the exec. Means when we call the exec function, the existing process saved set user ID will be copied. If the file set user ID bit is set, this copy is saved after the exec stores the effective user ID from the file's user ID. Okay. So these two tables, we can give the brief things how the ID can be changed. Okay. In the first table, just we can make the observation. ID means real user ID, effective user ID, saved set user ID. So when we call the exec functions with respect to this one, saved set user ID bit is off and saved set user bit is on. Okay, it is only one time we need to take it. Sorry, it is by mistake. Okay. So this real user ID is unchanged. Just we can make it. In this case, if bit is off unchanged, only the saved set user ID change that to be effective user ID. This value will be assigned here. Next, bit is on, real user ID is unchanged, set from the user ID of the program file. Means whatever the new program we are running, with respect to that one, the real user ID will be taken here and copied from the user ID. This value will be taken here. Okay. And with respect to super user privileges, as I already told you, if you are super user, then all the value is saved to UID here. Just we can make the observation. If suppose you are not a super user ID, then only effective user ID will be changed. In addition to those two functions, we are having the two more functions here: set real effective user ID, set real effective group ID function. The purpose of these two functions, swapping of an real user ID and effective user ID with the set real ID function, means if suppose I wanted to change from effective user ID to real user ID and real user ID to effective user ID, in that case I need to use the set real effective user ID function. It is with respect to user ID. If suppose you wanted to change with respect to group ID, then I need to call the set real effective group ID here. Next, two more functions. That's what. Just we can make the prototype of that, as I'm having the two arguments here: real user ID, effective user ID. So we can swap here. Okay. Similarly, we can swap here. Okay. Both return 0 if they are successful, -1 on failure condition. We can supply a value of 1 for any of the arguments to indicate that the corresponding ID should remain unchanged. Means if you are not interested to change any values, just you need to pass the one of the argument value should be 1. The rule is simple: an unprivileged user can always swap between the real user ID and effective user ID. This allows set user ID program to swap to the user normal permission and swap back again later for the set user ID operations here. Then set effective user ID function, set effective group ID functions. So these functions are similar to set UID and set GID functions, but only the effective user ID and effective group ID change. Means in that case, set UID function, all the value will be changes. but here only one value will be changed, that will be effective group ID and effective user ID here. An unprivileged user can set its effective user ID to either its real user ID or its saved user ID. Okay. For privileged user, only the effective user ID is set to UID here. I think this block diagram will clear what exactly the things has been happened here. And the one example I wanted to take here. If suppose you are having the super user privileges, we are having the super user privilege. Okay. Next, what are the values are, see that super user privileges, then you are calling the set UID functions. See that UID is set to real user ID, UID is set to effective user ID, and UID is set to saved user ID. If suppose you are not the effective unprivileged user, just we can find it here. Real user ID is set to only this one. This one means both the values are remain same. Okay, so from this diagram we can, whatever the things I covered, the same thing will be covered here. Next, interpreter files. I think in the cell program we can have a one path name. It is begin with the exclamation, hash mark with exclamation. Okay, optional argument. So this text line, what I can call as a interpreter file. The space is between exclamation point and the path name is optional. Okay, this is what I am talking about. The most common of these interpreter files begin with the line. See that, as I told, in the cell program we are always including this statement that indicate that whatever the lines as I am including in the program, that will be executed by the one interpreter that is named as cell. As we know that cell can also called as an interpreter. Okay. The path name is normally an absolute path name since no special operations are performed. Okay. The recognition of these files is done with the kernel as part of the processing of exec system call. The actual file that gets executed by the kernel is not the interpreter, the file, but the file specified by the path name on the first line of the interpreter file. Mean the cell is providing the one, say for example, if I am executing the one command, so in that case the command file will be executed, not the interpreter here. Okay, that you should understand. So we have one program, then it is more clear. This is a simple program as I have taken here. Okay, interpreter file consent. Just we can make the observation here as I have taken test interpreter here. This test interpreter, what exactly it contains, if I wanted to check it by using cat command, so this is the output here. At the end we can find echo.arg is the one file here we wanted to execute. Echo.arg, I think it is nothing but already we discussed displaying the command line arguments. So if I run this program, then what is the output I will get it? This is the output, because command to be executed is this complete line, that is echo.arg. So argument 1 is should be 4, then argument 2 should be this one, my argument 1 is argument 3, then my argument 4 should be this one. Okay, so what we need to understand is that whenever we are executing interpreter files, the file exists in the interpreter will be executed, not the interpreter itself. Okay, that we need to understand. A text file is of the for hash with exclamation mark, the complete line what I can call as an interpreter file. Okay, so this is about the interpreter files. I'll discuss more about in the next video.